12.2 Surface areas of prisms and cylinders. Our focus today is up on prisms. Prisms are polyhedrons with two bases that are congruent and lie in parallel planes. So, for example, we'll just select this as one of the bases. If that's a base, this is also going to have to be congruent to the first base, and they need to be parallel to each other. To name a prism, you name it by its base. So this is a rectangular prism, where this prism's base is a pentagon, so you say it's a pentagonal prism. Here's a triangular prism. And last, this is not a prism. This is just a cylinder. All right, the lateral faces. So the bases are what we did in blue. The lateral faces are the faces connecting. That's a lateral face. So all of them together would be the lateral faces. It's the polygons connecting the bases together. So we're going to look at finding the area, and we have of like a cereal box shape. Okay, it's a rectangular prism, and one way you can do this is to draw a net. So if I imagine cutting this down so this would lay flat, to find the surface area, it's the outside area of that box. And you could then label some of these dimensions, like 5, this is 5, this one would be 17, and this would be 16, 16, and this would be back to 5. So we could figure out the area of each one of these boxes by taking 16 times 17, and this would be 5 times 17. This would be 16 times 17 again. This is 5 times 17. We got to figure out what this length is. Notice if I folded this box up, this side would match up with this side, so I know this is going to be 16, and that's going to be 16. So this is 5 times 16, 5 times 16. So I could do all these calculations, figure out the area of each one of these boxes, and add them together. Or there's a trick. I look at this, and how I would do it is I would look and I'd find the area of this box here. The area of that box is going to be 16 plus 5 plus 16 plus 5, or 42. Okay, that side length's 42. This side length is still 17. So it'd be 42 times 17, plus I still need to find the area of these two boxes, 5 times 16, but I have how many of those? One up here, one down there. I have 2 of them. So I could now find my answer by taking 42 times 17 plus 2 times 5 times 16. And I get 874 units squared. Okay, make sure you focus on labeling it right. We're still talking about surface area, how many squares fit in this box. Now, we can generalize what we did here into a formula. The surface area of a prism we're going to have two bases. So 2 times the area of the base. The capital B means base area. And plus this length here, the 16 right here. This is what I called the base in this problem. Okay, 16 plus 5 plus 16 plus 5, that's the perimeter of the base. Perimeter of base. And I took the perimeter of the base, this side length, times the height. So notice the height in this case is going to be measured at a right angle to the base. So in a rectangular prism, it doesn't really matter which one you pick the base, because both of these are going to be congruent and parallel. Other shapes it will matter more. But this is a formula for surface area of a prism. Okay, surface area of a right prism is going to be 2 times the base area plus the perimeter times the height. This is a triangular prism. So my base is a triangle. So when I want to calculate the area of my base, I'm going to use 1/2 base times height. Note, this B is the base of the triangle. Okay, it's different than the capital B. This is the base area of the prism. Now this formula will change. I get a lot of people confused. Formula changes depending on the base. So in this case, since our base is a triangle, we use this formula. So I'm showing a lot of work. I'm taking the base, the area of the base. If this is 10 and this is 10, remember these shapes are congruent. This is measured at a right angle, so it's going to be 1/2 10 times 10, which is 50. That's my base area. My perimeter, it's the distance around, 10 plus 10 plus 15. 10 plus 10 plus 15, or 35. And the height is the distance between. Okay, distance between measured at a right angle, that distance is 11. Once I figure this out, I can plug it into the formula and get my answer. Surface area equals 2 times 50 plus 35 times 11. So we get 100 plus 385. So my surface area is 485 units squared. Okay, so make sure you use your formulas. You know, use multiple formulas, not just one formula. Take your time, make sure you identify the shape of the base, use the right formula. Don't get mixed up with the capital B and a lowercase b. They mean different things. Capital B is a base area. And this is just a net of that shape. Okay, flatten it out. Notice the triangle, you know, imagine these sides reaching up and touching this side and folding this back into that shape, that three-dimensional shape. Find the surface area of a right cylinder. This is my diameter. My radius is going to have to be 11. And now to find the area of this rectangle, that's going to be the circumference. Okay, that's my circumference of the circle, which is 2 pi r. So this side length is 2 pi r. This side length here is going to be my height. So the area of this rectangle is 2 pi r times my height. And we have two circles, so 2 times the area of the base plus the perimeter times height. That formula still works. This is not technically a polyhedron, so it's not a prism, but the formula still works. We can make it specific for this problem and substitute, instead of a circle, the base is a circle. So we can use 2 pi r squared. Pi r squared is the area of a circle. We have two bases plus the perimeter, circumference. 2 pi r is the circumference times the height. Circumference times the height. Pi r squared, area of the circle, two circles. Okay, this is a generalized formula for any cylinder. For our cylinder, we're going to substitute in r equals 11, h equals 8. So 2 pi 11 squared plus 2 pi 11 times 8, which is 1,313.18 units squared. So finding the surface area of our right prism, we might have to, finding the area of a hexagon, you might have to do some formulas from chapter 11. The area of a hexagon, well, here we know the apothem. 6.9 is our apothem. And I misspelled that. There we go. Our apothem, and so our formula for any regular figure is 1/2 the apothem times the perimeter. Now this perimeter is the perimeter here, so 1/2 6.9. The perimeter each side is 8, so 8 times the number of sides, 6. This is going to tell me the area of my base. That formula we use differs depending on the shape. And we get 165.6. So we also need to know the perimeter, which is 6 times 8, and the height, which is 14. So now we can use the formula 2 times our base area plus our perimeter times our height. The surface area, plug in 2 times 165.6 plus 48 times 14. Our surface area is 1,003.2 units squared. Find the height of a cylinder that has a radius of 9.5 inches and a surface area of 925.2. So using the formula for a surface area of a cylinder, 2 times the base area, our base is a circle, plus the perimeter, 2 pi r times the height, and plugging in 9.5 in for the radius, I can solve this thing. For h. I'm going to calculate this number, I'm going to calculate that number, and I'm plugging in the surface area of 925.2. Okay, so I did a little bit of calculations. I calculated out what that number is. I calculated out what that number is. Now it's just a two-step equation. I subtracted 567 from both sides, and then I divided by 59.69 from both sides, and I get h equals 6.0001 something. So I can say the height is in inches. So my answer, the height of that cylinder would be 6 inches. There's your homework assignment, 12.2. And if you're watching this at night, I can say night-night, termite.